Okay. So let's do a quick recap, guys, with the current architecture, so that it will, it will give us idea to start with the new architecture. So what you have is like in current architecture, you have the two admin node or two admin process, basically the name node and the job tracker. So what the name node does is it does the storage part of your Hadoop processing, like whatever you want to store, where you want to store, how to retrieve, all those kind of the information you coordinate with the help of the name node. What the job tracker it does, it basically does the execution part. So whenever you want to execute any kind of job inside the Hadoop cluster, it will be done with the help of the job tracker. So what you have in case of Hadoop cluster is like the coordination will be done by the name node, but all the actual storage of the data, it will be done with the help of the data node. So data node is a process that will be running on each slave machine, and it will basically take, it will coordinate with the name node, and it will take the instruction from the name node, whatever the allocation is done by the name node, and based on that, it will go ahead and store the data. Right. Similar way, you have the job tracker and the task tracker. So job tracker is going to basically take care of your execution of the data. And whenever you submit a MapReduce job, it is basically the responsibility of the job tracker to decide how many number of the mappers it's going to run, how many number of the reducer you have submitted, and based on that, it is going to create so many instance of the map job, and it will keep tracking all the map jobs which is running. So basically the whole life cycle of your MapReduce job, it will be maintained by the job tracker. So if you guys ever remember our discussion about the speculative analysis, so if one of the mapper it fails, it will be the responsibility of the job tracker to manage the life cycle of that particular application. And in case of the failure, the job tracker is the one which is going to take care of like starting that job again on some other machine. So that's the responsibility we have the job tracker. And this job tracker is, again guys, it's a single process that will be managing all the resources in the cluster. So means like if you have like 10,000 mappers running, so all those 10,000 mappers life cycle, it will be maintained by a single job tracker thread. So job tracker in itself, it just do the management of this life cycle of the jobs, but the actual execution of the job, it will be done with the help of the task tracker. So job tracker will assign those tasks to the task tracker, and then task tracker will take that particular piece of the code which is assigned by the job tracker, finds out the the corresponding data set which it needs to feed that particular code with the help of the data node, and then the execution starts on each of the worker machine. So that's what we had pretty much the architecture in the Hadoop 1.0. I hope you guys are clear with this particular architecture. Along with this, what we had is we had this secondary name node concept. So this concept, what it does is since this name node maintains all the metadata in memory, so at any point if this name node goes down, so what will happen is your cluster will have outage, and you will not be able to access any file inside the Hadoop cluster. So that's where you have this secondary name node concept, which basically keep connecting to the name node, and based on the frequency you set, like every half an hour or 1 hour kind of thing, it takes whatever the metadata it is having in memory, the backup of the metadata in memory, and then it stores on the file system. So that's what the kind of the architecture we have with the name node and the secondary name node. Okay. So with the current architecture, guys, let's understand like what are the current challenges we have with the the architecture which we just saw with Hadoop 1.0. So one of the challenge what we have is with the name node. So what you have the challenge, the first challenge with the name node is basically one is high availability, and the second challenge is there is no horizontal scalability. So what this means is like whenever you talk about the Hadoop architecture, one thing we talk that whenever the data size grows, what we do is we add a few more nodes inside the cluster, and then we add basically the more storage capacity as well as the processing power. So that's what the architecture we have with the Hadoop 1.0 architecture. So in this mechanism, we have a way to store or basically to scale when the data size grows. But then what we don't have is like how we can grow the name node, which basically maintains the metadata about the system. So if you think of about a Hadoop cluster with the current 1.0 architecture, what you will have is like you will have one machine, and that will act as a name node, and it will have maybe the main memory like 64 GB or 128 GB kind of, even nowadays a more number of 256 GB kind of the memory, right? And then you will have set of the data nodes that's working along with that particular name node. Now, what will happen is like each file what you are going to store inside the Hadoop cluster, that is going to have the metadata stored inside the name node main memory, right? So that's what the architecture we have for the name node. So at one point, what you may hit a limit is like if you have too many files that get stored inside the HDFS file system. Although you can still grow in terms of the data node, you can add the more machine, but then you will hit a limitation in terms of the name node main memory, because you will not be able to grow after a certain limit or after all the main memory is used for the metadata. So in that case, you have a kind of a limit, like how much maximum you can store inside the Hadoop file system. And since in the current architecture only one name node supports, so you will like whatever metadata you can store with the name node main memory. So that's basically kind of the limit you have about like how much data you can store inside the Hadoop cluster. So since in the cluster you are going to have a single machine, so it's going to have single namespace, and it's going to limit that by the whatever the RAM you have with the name node. So the second thing, or the second challenge what you have is basically the availability of the name node. So as we know that there is going to be a single name node inside the Hadoop cluster, so it is going to be a single point of failure. So at any point if the name node goes down, your cluster is going to have the outage. And then recovery using the secondary name node, it's going to be a manual process. So that's again basically brings the availability of the Hadoop cluster down. So nowadays enterprise, like when you put a lot of data inside HDFS and want to basically have the availability, the current architecture is somehow not, although it's able to process the huge volume of the data in a reliable way, like having the replicated data, but then when it comes to have a number in terms of the availability, it doesn't have the high availability kind of thing. Then what you have is the another stuff, or another kind of the challenge we have with the current architecture is with the job tracker. So as I told, the job tracker is a single thread which is maintaining all the number of the mappers and the reducer inside the Hadoop cluster. So what it does is it's basically spend a significant time in terms of managing the whole life cycle of the application. And that's where at some point you will see that the job tracker is not able to use the whatever the available resources we have inside the Hadoop cluster for the MapReduce processing. So we'll see with the new architecture, it is somehow simplified, and you will see that job tracker is more optimized to handle the resources what we have inside the cluster. Okay. And then the fourth challenge, what you have with the current architecture, guys, is basically the kind of the limitation you have with the Hadoop 1.0 architecture. So if you talk about the Hadoop 1.0, like whenever we are talking, whether it's MapReduce, HivePig, we always saw this constant that if you want to process or if you want to do any kind of computation for the data which is available inside the Hadoop file system, it should always done with the help of the MapReduce job. So what you do is, you submit a MapReduce job, or you convert your algorithm or the processing in terms of the MapReduce job, and then it execute that on the Hadoop file system. Now, if you see the current trend in the organization, how they are using the Hadoop, so basically they are bringing a lot of data set inside the Hadoop file system because of its availability and the reliability. So once your data is available in HDFS, you want to process it, you can have multi-tenant system which want to basically consume the data and process the data. But due to the limitation what we had, like all the execution on the Hadoop file system or the kind of the coupling we have, tight coupling we have with the Hadoop file system and the MapReduce. So you have to convert your existing algorithm into the MapReduce job, and then only you can execute inside the Hadoop file system. So that makes basically a few things difficult. Like if you want to do certain graph processing kind of algorithm, if you want to some in memory kind of processing, so those kind of application, it becomes slightly challenging to do with the MapReduce way of implementation, because those algorithms may not be easily ported as a kind of the MapReduce architecture. So some algorithm even may not be able to convert as a MapReduce job. So how to use this huge volume of the data for other processing? We'll see that with the new architecture, that's become slightly possible, and there this constraint like just having Hadoop and the MapReduce is get a little enhanced, and it basically able to be the new yarn architecture. It will be able to take all other kind of the processing as well on the Hadoop file system. Okay. So this is the challenge what we had with the Namenode, guys. So there were two challenges with the Namenode. One was the scalability, and another one was the availability. So you have the scalability of your data node. So as the size grows, you can add the more data node, and your system can keep growing in terms of the storage and the processing. But when it comes to the Namenode, it's always going to have the single machine that's going to act as the Namenode process, and then it's going to manage all the blocks inside these data node. So once this Namenode main memory is filled, so that's basically you are going to hit the limit in terms of how much data you can manage within these data node, right? So that's what like one of the kind of the limitation we have with the Namenode, like how much metadata you can store in memory. So even though you had the option to add more data set here, but since all the space is filled here in the Namenode main memory, so it will not be able to store any more data, and that's where you will not be able to scale in terms of the current architecture. So now the next thing what you have is the Namenode high availability. So since the Namenode is going to be a single process that will be running inside your Hadoop cluster, so at any point if this particular machine goes down, you don't have basically an automatic mechanism to switch over to the next machine, and your whole the effort in terms of bringing another parallel Namenode machine is going to be it's going to be a manual process, and you will take the help of the secondary Namenode, and with the help of the secondary Namenode metadata that it is stored on the file, you will take that metadata and you will bring another machine as the Namenode. So it's all, the whole process is going to be a manual process, and that's where you will have the challenge in terms of predicting the availability of the system. Okay. So I hope you guys remember this diagram as well, guys. So this diagram where we talked about the Namenode and the secondary Namenode, how it works. So the secondary Namenode, it's not a standby kind of the Namenode. So it connects to the Namenode every hour, like that's the default frequency what we have, and it does the housekeeping by doing the backup of the Namenode metadata. And once that backup is done, it will save that metadata on the file system, so that in case of the Namenode failure, you can take this information and then you can bring back the Namenode as a kind of as a kind of in case of the failure, you can bring that machine with the help of the files which are backed up by the secondary Namenode, right? So these were the challenge what we had, guys, in terms of the storage. So one is like Namenode not becoming highly available because of this single machine, and the other one is like Namenode not is something which is basically able to scale. You have the one single instance of the Namenode that manage the whole cluster, right? So is these two challenges clear with all of you guys in terms of the Hadoop 1.0 architecture? Do you agree that these are the challenge we had, and we need to basically have a slightly different architecture where you can manage this? Okay, so once we see the challenge, guys, in terms of the storage part, and especially with the Namenode part, so now let's see the challenge what we have with the job tracker. Basically, you spend a lot of time in managing the life cycle of all the application. So in case of the job tracker, what you have, guys, is like you have a single thread, that's the job tracker, and that maintains all the applications. So when you talk about all the applications, so all the different mapper and the reducer that we run inside the cluster, that will be maintained by the job tracker. So it is going to be like a lot of overhead for the job tracker, because it has to manage all the different mappers that's running inside the cluster. So like as we understood, like suppose if you're processing 1 GB of the data and the block size is 64 MB, it will have around 16,000 mappers that will get created. So it has to manage the life cycle of all those 16,000 mappers inside the cluster, and at any point, if this mapper fails, it will be basically the responsibility of the job tracker to take care of that and restart it on some other machine. So that becomes a lot of challenging task for the job tracker to manage such huge volume of the application, and basically at the same time utilizing the cluster resources also in terms of the scheduling the task. Right. So all these challenges together, guys, basically having this Hadoop 1.0 architecture, which is not highly available, and then the job tracker in a single thread, you up to some extent what happens in case of the failure, like if you have a bigger cluster and if there is any kind of failure, you have no way to basically tell that when your server is going to be up and online. So because this process is going to be manual, recovery is going to be manual, so it's going to take time. And also since nowadays you have the multiple kind of the application which connects to the Hadoop, and then they want to do the processing. So since the current Hadoop 1.0 architecture, it limits the processing only with the the MapReduce job. So in a multi-tenant system, it becomes slightly challenging, like how to use such huge volume of the data that you have stored inside the Hadoop cluster by any other application, and that's not the MapReduce job. Okay. So as you can see here, how the data footprint is growing inside the Hadoop file system, guys. So you have terabytes and the petabytes of the data that you are storing nowadays inside the Hadoop file system, and it can with the current architecture, it can only used by the MapReduce processing. So if you have anything else, this huge volume of the data you will not be able to use for any kind of the processing apart from the MapReduce. Okay. So now what we have is this Hadoop 2.0. So now we will get introduced with the Hadoop 2.0 architecture, guys, and that's where we'll see that how we can overcome these challenges in terms of the architecture, current architecture what we have with Hadoop 1.0. How in Hadoop 2.0 these things will be taken care by enhancing this particular architecture. So whenever you talk about the Yarn or Hadoop 2.0 architecture, guys, it is very important that you understand the current existing architecture, and based on that, you will be able to relate how these things get improved with the new Hadoop 2.0 architecture. Okay, so when we are talking about the Hadoop 1.0 architecture, guys, we basically saw the challenge on the two places. One was on the storage side, where you had the Hadoop file system, and you wanted to have basically a reliable storage on inside the system, and you wanted to have the scalability of the name node. So as you grow with the data node, you can similarly increase the name node main memory as well, so that you should be able to store more data inside the cluster. So that's where what you get in Hadoop 2.0 is basically you get the federation of the name node. So in Hadoop 1.0, what we had is we had one name node, so it will have the single namespace. What it means is, so if you have one machine that is acting as the name node, so whatever the RAM is available for the name node, so that's the namespace you have to store the metadata, right? In Hadoop 2.0, what you have is you have the multiple name nodes. So that's what you have, the multiple namespace. So what it means is, now you can have multiple name node inside the Hadoop cluster. And like if you have like 2 name node inside the Hadoop cluster or 3 name node inside the Hadoop cluster, so each of them can store like 64 GB of the data, right? So so that way you basically enhance. So tomorrow if you hit a limit in terms of all these 3 name node machine, like whatever the data it can store. So in that case, what you can do is you can add the fourth machine inside the cluster, and then it will have again 64 GB. So you can store more data inside the Hadoop cluster, and that will be managed by the fourth name node. So that's the kind of the architecture you are going to have with the new Hadoop 2.0 architecture, where you will have multiple name node instance that will be running inside the cluster. Okay, so that's the one major enhancement you have with the Hadoop 1.0 to Hadoop 2.0. Okay, so one thing was the federation, guys. So instead of having one name node and the single namespace, now you are going to have multiple name node and multiple namespace. Second thing is the availability of the system. So if you talk the Hadoop 1.0 architecture, what we have is whenever the name node goes down, so at that point you have only the concept of the secondary name node, but then the whole process of recovering that the name node with the help of the backup files created by the secondary name node, it's going to be a manual process. So now with the Hadoop 2.0 architecture, what you have is you have the automatic kind of the switchover in case of failure. So you have this, the standby nodes which basically share the logs, and based on that sharing, if at one point if one of the instance of the name node goes down, the another instance of the name node will take over immediately. So you don't have any manual process to basically switch over from the failure name node, and that way you will see that it is like a highly available kind of a system that you will have inside the Hadoop cluster now. Okay. Then the third thing, what you have is basically enhancement in terms of the processing. So in Hadoop 1.0, what we have is the job tracker and the task tracker that acts as basically a processing mechanism inside the Hadoop cluster. So now with the YARN architecture, this part has been a bit simplified, and you have a little bit more terms in terms of managing the whole stuff. So now you have the concept of this resource manager, node manager, application master, and the capacity scheduler. So with the help of all these, what you do is you manage the Hadoop cluster in a much better way now in Hadoop 2.0. So we'll see in the flow like how these things interact with each other when it comes to the submitting the MapReduce job and executing with the Hadoop 2.0 architecture. But here let's quickly get introduced with these terms, guys. So resource manager is something like which controls the usage of the resources across the Hadoop cluster. So all it will do is it will see like what all the resources it's available inside the cluster and who is utilizing that. So all those things will be maintained by the resource manager. Then you have the concept of something called the node manager. So that's going to run on each of the data node that we are going to have in the cluster. So each of the data node, it's going to run something called the node manager. So instead of having your task tracker, what you have is now that node manager that's going to run. And it's going to basically create something called the execution container, and that will be basically executed on each of the worker machine or the slave machine which you have inside the cluster. Right. Then the third thing what you have is basically the application master. So that basically coordinates and manage the, like whenever you submit now a MapReduce job, so that whole job stuff it will be managed with the help of the life cycle of that job will be managed with the help of the application master. So what this application master is going to do is it's going to basically work with the resource manager to schedule the task, to get the resources, and based on that it will take the help of the node manager to execute that particular task on each of the slave machines. So we'll see more detailed diagram of this one, guys, how the whole interaction works. Okay. So at this point, guys, let's see the new architecture, the Hadoop 2.0 architecture. So what you have in this particular architecture, as you can see here, guys, so on the left hand side you can see the Hadoop 1.0 architecture. So that will help you to visualize and relate how the things changes in Hadoop 1.0 to Hadoop 2.0. If you see the architecture in Hadoop 2.0, we had the single name node, and that's what it was maintaining all the blocks inside the cluster. And then we had the multiple data node that will basically are distributing the load in terms of the storing the data. Now with the Hadoop 2.0 architecture, what we have, guys, is like you have the multiple name node now inside the cluster. So you have like one name node that maintain one set of the data, then you have another name node that maintains another set of the data inside the Hadoop cluster. So that way, basically, you are able to have the more namespace in terms of the name node main memory, and then you have set up the data nodes. That's where the actual data that gets stored. So with this particular stuff, what you are seeing here, you are basically able to scale the name node here, and you are basically overcome the limit which we have, like a single machine, whatever the maximum number of the RAM it can have. So that's the kind of the metadata that you are going to store. That's the maximum number of metadata that will store in the name node main memory, and that will indirectly limit you like how much data you can store inside the Hadoop cluster. So that's what we had with the current Hadoop 2.0 architecture, guys, where you have now the multiple name node, and that's basically take care of the storage. So now what you will have is like as you can see here, so different blocks of the data, it will be basically managed with the help of the multiple name node which you are going to have inside the cluster. So now once we understand about this the availability aspect of the federation aspect of the name node, now let's switch over to basically understand the availability of the Hadoop 2.0 architecture. Okay, so let's see about this Hadoop 2.0 architecture in terms of high availability, guys. So as you can see here, one thing is what we have in the Hadoop 2.0 is we are going to have the multiple name node, and a multiple name node going to manage the multiple namespace. So basically we are going to achieve the horizontal scalability by adding the more number of the name node inside the Hadoop cluster. So that's one part, and that's what we are clear. The second aspect we have is with the availability of the system. If you remember our the Hadoop 1.0 architecture, what you have is you have the name node that's running as the name node machine. And then in case if there is any failure or something, so in that case the name node goes down, and then you have the secondary name node that basically takes the backup of the metadata. You bring back that metadata, and then start that machine again as the name node kind of thing. In case of Hadoop 2.0, what you have the architecture is like you have the active standby node and you have the standby node. So what it means is like if at any point if this machine goes down, you will have another machine that will take over immediately. So that way what you are going to do is you are going to have this availability of your system is going to be very high, because it is having this particular kind of the configuration where the recovery it happens automatically. So you have this kind of the cluster, this kind of the architecture is not new, guys. With the Hadoop itself, you have with the normal Linux system or Windows system also, you have this kind of the architecture where one of the machine goes down, other machine will immediately take over and start handling all this stuff. So how it does that is that does with the help of something called the shared edit log. So whatever kind of the operation the current name node is doing in terms of the update, delete, all those kind of the steps are going to be handled with the shared edit log. So the information will be available in that, and that is going to be shared between the active name node and the standby name node. So when whichever machine goes down, the other machine will take over immediately with the help of the shared edit log that is shared between that. So now since you have this active and the standby kind of the mechanism in the Hadoop 2.0 architecture, so if you want to have the secondary name node, so that becomes an optional kind of thing. So if you want to have much more reliability, that okay, you have the active name node, then you have the standby name node. If there is any failure on the active name node, the standby name node will take over. But at that point, if there is any failure in the standby name node and you want to have a backup mechanism, you can have the secondary name node. So it becomes completely an optional kind of thing now to have the secondary name node with the Hadoop 2.0 architecture. But as per the framework, yes, you can have this also as part of the Hadoop, as part of the Hadoop architecture. Okay, so let's see some more concept, guys, and that's basically in terms of the processing. So these are the currently architecture changes we had with the in terms of the storage, so that the HDFS part which we saw. Now what we are going to see is we are going to see in terms of the processing side how it's going to happen. Okay, so in terms of the processing, what it's going to do guys here is instead of having a job tracker and the task tracker to manage all the execution inside the Hadoop cluster, now what we have the concept of the resource manager and the node manager. So that's where the way how the jobs are getting executed now. And one more shift what we have with the Hadoop 1.0 architecture to Hadoop 2.0 architecture is basically managing the life cycle of the application. So if you talk about the Hadoop 1.0 architecture, so there whenever you submit a MapReduce job, once the job is submitted, it will be the responsibility of the job tracker to manage all the number of the map and the reduced tasks that we are running inside the cluster, and whether it fails or succeeds. So that's going to be basically managed with the help of the job tracker. Now, in case of Hadoop 2.0, you have that responsibility divided, and that will be basically the managing the life cycle of the application that is going to be done by the application master. And apart from the managing the life cycle of the application, what it's going to do is the application master. That's what we see here, the new concept here, the application master. So apart from that, what it's going to do is it's going to coordinate and manage. Like if you talk about the MapReduce job, so it's going to have its own the application master. So it's going to coordinate and manage the MapReduce job inside the Hadoop cluster. And to execute your MapReduce job, it's going to negotiate with the resource manager to get allocated the appropriate resources. And once those resources are allocated and the task is scheduled to run, what it's going to do is it is going to basically go back to that node manager, and then it is going to ask to execute that particular job on the data which is lying inside the Hadoop cluster, right? So that's the way how this the resource manager and the application master is going to work. So now the life cycle of the application, it will be managed by the application master. Negotiation about the resources, how many number of the CPU you want, how much memory you want. So all those kind of the things is now going to be negotiated with the resource manager, and resource manager is nothing but simply it will have the visibility about all the available resources inside the cluster. So it is going to use that to decide whether it can go ahead and allocate a certain amount of the memory or CPU or not inside the Hadoop cluster, right? And then once that storage happen, it comes to something as the container. So what it happens in terms of the execution is you take this container, give it to the node manager, which execute that, as well as it monitors slightly the kind of the usage pattern it has, and based on that it will report it back to the resource manager about if it is like like if it is allocated just from the app manager, like kind of 1 GB of the memory, and it's using like for the join or something, it's using like 4 GB of memory. So that is going to be basically reported by the node manager to the resource manager. So at this point, if you want to understand about the container, so it's nothing but it's like whatever the allocation you have from the resource manager for the execution of the job, like how much CPU it can use, how much memory it can use, what's the priority. So based on that only you are going to get the resources allocated. So all those stuff, it will be part of the container. So let's see about the the Hadoop 1.0 and 2.0, guys. So you had the name node, and what the name node it has is it has the manual recovery process in case of the failure, and that's where you have the secondary name node that reads the data from the edit logs and the image file, and then it play it back, and then based on the data you recover the name node. In case of Hadoop 2.0, it is automatic failover, and to do that what you have is you have the concept of this active standby name node and the standby name node. So they basically both basically do a kind of automatic failover whenever one of the machine goes down, And then you have this, the secondary name node. That's nothing but an optional kind of thing. So if you want to have the concept of secondary name node, you can have that as well, which will connect to the name node which were acting, and then takes the metadata from that. Okay, so let's summarize this discussion, guys, what we had here. So in Hadoop 2.0, you have the concept of the active standby name node and the standby name node. Along with that, what you have the concept of, you can have the multiple name node inside the cluster. And then the secondary name node, it becomes the optional stuff. And then in terms of the processing, what you have is, you have the the concept of something called the resource manager and the node manager. So you can see the responsibility of the resource manager is to manage the resources or schedule the task. And once the task is scheduled, the whole execution is going to be done with the help of the node manager. And what it's going to have is, it's going to have this component the container, which will contain all the necessary information about how to execute the job. And then you will have the application master that will be basically controlling the life cycle of this particular application. So that way, this get also more enhanced in terms of the high availability of the system.